T1, Tr, which are fixed for the exponential here, which are complex numbers linearly independent of a Q. Q1, Qs, which occur here, are complex numbers so that omega 1, omega 2, Q1, Qs are linearly independent of a Q. This was exactly the condition for the algebraic independence of the functions. So if we have algebraically independent functions, then for almost all tuples, Z1, Zn, all these numbers are algebraically independent. So we have a statement which is not a conjecture, but now we would like to have a conjecture which is valid for all tuples, not almost all, but all tuples, like in Chanuel's conjecture. We have n free parameters, Z1, Zn, and in the case of Lindemann-Weierstrass, we take the Zi, which are algebraic, and so the transcendent degree is only n. Here it's the same. The conclusion of the conjecture, we had n s plus r plus 4, but we cannot expect that transcendent degree for all Z1, Zn, so we will have n less, so n times s plus r plus 3. So this should be the conclusion. We cannot expect better than that. Now, the result was with a field which is finitely generated of a Q. We cannot take any field. We have to take a number field, and we can take Q of G2, G3, which is what we will do. Then we need some assumption on the Zi. The previous result was for almost all Zi. In this case, they are linearly independent. But here we need at least that they are linearly independent over the field of endomorphism of P. Otherwise, we have trivial relation. And also, it is natural to assume something on P of Qi. And so if we put all that together, we can get some statement. But if we want to have a good ground to state a conjecture, the best solution is to take a geometric point of view. So I give a statement which we consider as a semi-elliptic conjecture of Chanuel. And to make things easier, I assume that there is no complex multiplication. In the case of complex multiplication, it will be slightly different, but not much. So we take the Pi, which are complex numbers linearly independent of a Q, the Qi with the same assumption as before, omega 1, omega 2, Q1, Qr are linearly independent of a Q, and we have Ts, which are linearly independent of a Q. And then the conjecture is that if we take all the numbers which are here, 3n plus r plus nr plus 2s, this is the number of elements which I write here, at least 2n plus nr plus s should be algebraically independent of the Q of G2, G3. So this is a conjecture that we suggest, and we have some reason to suggest such a conjecture, which comes from geometry. So we consider the algebraic group G, which is an extension of the elliptic curve by the multiplicative group, which is parameterized by a point which is the exponential of Q on the dual elliptic curves. So the Q occurs like this to parameterize the extension of the elliptic curve. And the fact that Q is not of torsion means that the elliptic curve, the extension is not trivial. And then there is an exponential, there is an algebraic group, which is a G, which is a Lie group. So it has a Lie algebra, and there is an exponential. And the exponential is parameterized by the sigma function, the P function, and the exponential, and the FQ function, which occurs here. So this parametrization is explained in the book by David Masser. He has a chapter on the elliptic functions, which is which contains a lot of things. And now, using this geometric point of view, there are some conjectures. The first one was Chanuel, then there was Grothendieck, and then, maybe Grothendieck was before, but, and then Yves André generalized the conjecture of Grothendieck and Chanuel, and he phrased a general conjecture on periods and generalization to motifs. And the case of one motif was developed by Christiana Bertholin, and she called this ellipticotoric conjecture. So it's based on this conjecture that we propose this elliptic, semi-elliptic conjecture. To conclude, I would like to quote something which is related with a kind of joke of David Masser. There is a recent paper by Senthil Kumar which was published in Acta Arithmetica, and David Masser wrote an appendix to the paper of Senthil Kumar, and the appendix has the title Rational Values of the Weierstrass zeta function. And David Masser points out that the result in the paper by Senthil Kumar has a consequence, which is that if the two invariants G2 and G3 of the elliptic functions are algebraic, then for the Weierstrass zeta function, one at least of zeta of 3 and zeta of 5 is a transcendental number. And we conjecture, in fact, it's a consequence of our conjecture that both of them, zeta of 3 and zeta of 5, should be transcendental. But David Masser writes, this may be found amusing by those who study another zeta function, and he adds a theorem which is that there exists invariant G2 and G3 such that both zeta of 3 and zeta of 5 are rational numbers. And from the result of Senthil Kumar, it follows that G2 and G3 cannot both be algebraic. So, based on this joke of David Masser, we propose the following result, which includes the Weierstrass and the Riemann zeta function. So we denote by zeta A the Riemann zeta function, and the first proposition is that if you consider the four functions z, p of z, zeta of z, and zeta A of z, we have four functions, and these functions are algebraically independent. The proof is not too difficult. We use the fact that for the Riemann zeta function, if you take z with real part which tends to infinity, then zeta of z is very close to 1. So essentially we eliminate z by taking z sufficiently large, and then we are back to the algebraic independence of z, p of z, and zeta of z, which I mentioned before. And so, as a corollary, for almost all tuples of complex numbers, the four n numbers which are here are algebraically independent of a Q of G2, G3. I started by giving a result that we are able to give an explicit example for the strong Chanuel's conjecture for the exponential alone. I must say that here I know that this is true for almost all n tuples, but we are not able to give a single example of such a tuple. And it's probably rather difficult to give it, even to give an example where we take only one of them, that the transcendence of zeta of z and zeta A of z is something which is essentially hopeless. So, thank you. We have time for questions.
Thank you, Professor Waldschmidt, on a beautiful lecture on a really fascinating topic. Thank you. Any questions for our speaker?
Yes, Shaoli.
So in which context does SAR define this function, this particular function you were looking at? SAR's function.
FQ of z?
Why SAR looked at this function?
Yeah, the function, you mean the function FQ of z?
Yes. FQ, yeah, f of q.
Well, in fact, I gave a course in the Collège de France in 1978. I was invited by SAR, and during my course I explained that we have the function z, p of z, and zeta of z, which are used to parameterize the elliptic integral, the first and second kind. And I said we do not know a function which would play the same role for the elliptic integral of the third kind. And SAR immediately told me, oh, this was known in the 19th century. And the next week he came back and said, I did not find a reference, so I wrote the result, and it is published in the appendix of my book in Asterisk.
Yes.
So thank you so much. I think the very last slide, in a way you eliminated the Riemann zeta function from the picture. Can you please explain how it reduces to the first three functions, that the last one does not matter so much, something like that?
You mean this one?
The algebraic independence of 4 functions.
Yes.
You said the Riemann zeta function in a way is dropped or eliminated and
Yes.
it reduces. Can you please explain how that
Yes.
happens?
We assume that we have a polynomial in 4 variables such that the function p of z, zeta of z, and zeta r of z is a 0 function. So this is the assumption that we start with. And so what we do is that we take z, which is sufficiently large, and we replace zeta r of z by 1 plus something which is very small. And so we divide the polynomial by, say, the last variable is x4. We divide the polynomial by x4 minus 1, and so we have zeta r minus 1 times something plus a remainder, and then zeta r minus 1 is something which is very small. So using some elementary analysis, complex analysis, we deduce the result.
Okay, since we have gone a little bit past time, other questions can be asked for the speaker when we have a little break. So let us thank the speaker again for a really beautiful lecture.